So I'm sure there are a lot of people with experiences here, industry experience, may have some suggestions that they want to give to us. So we're willing to answer some questions, but at the same time, kind of engage in some constructive discussions on way forward with issues like this, with technologies like this and things.
Questions. One, did you have any issues with planning authorities? And then secondly, a suggestion, but also a question. When you consider solar power now, do you automatically consider battery storage?
Thank you for the question. I think the first part of the question regarding planning permission, surprisingly no. But I think this is as a result of the good relationship that Coventry University have with the planning authorities. Our team in the Estate Department engaged in some conversation at the beginning of the project regarding the installations, and I don't think they considered it as significant, material change. Also, the fact that it is a short-term research project maybe swayed them a little bit, so we didn't have any significant problems there. Regarding the second issue of storage, I think now the direction is towards storage. But in our case, in the case of this particular project, the experimental system that we have in the John Lang building, yes, we have storage, and we consider storage. In the Richard Crossman building, no, we did not consider storage, and I can understand why we didn't consider storage, because Coventry University have a large energy consumption, electric energy consumption, so anything that solar PV or any renewables that we have on site generates, we consume. So there is basically no need for storage in there. But definitely, I think there is continuous movement towards having more storage, because the more of your energy that you generate that you can consume in your property is better perhaps than the feed-in tariff that people get. So I would imagine that in the coming years, and with the improvement in the efficiency of the battery storage and the size of the battery storage, I would imagine that will be the direction of movement over the coming years. Did I answer that? But what's your perspective?
I agree with that entirely. See, way forward, if you don't install solar, you've got an opportunity when you install it at the same time, rather than think about it afterwards. So that's the idea.
Hi, Archie Corliss, Encraft. I just want to ask around the PV, particularly the building integrated PV, because on a vertical facade, typically you might get, say, 30% less generation than you would if it was tilted at 35 degrees. Have you done any comparisons between the generation you got from the building integrated PV versus rooftop PV?
I think that's currently ongoing at the moment. So so basically we're going currently we got the setup for the ventilated facade running quite recently. We needed to get that done as soon as possible because the project's coming near its end. Right now there's a load on it to see how much energy we're actually producing right now. But the main thing is having the PV with the ventilated facade, in the sense that we have a form of insulation as well as ventilation and as well as energy production as well. So the whole system, we consider it as a whole system rather than just solar panel and solar panel.
Hi, I'm Maxwell from Croya. Around the PCM, how much information was available from the manufacturers regarding installation, as in the spacing to allow for airflow for the heat exchange to the PCMs to then supply to your contractors, and also information on why they were not black if they're to primarily absorb heat. Just wondering, like with the PCM, is it still very much kind of in development by the manufacturers? and what information they could provide to you in terms of assisting you in the installation.
I think, sorry, just quickly, I think they did provide us some basic structure for the installation, but obviously that is building specific. You have to consider it within the context of the building that you're installing in. We did have to do a structural survey, number one, because we know that will add significant weight load to the roof structure. So we have to commission a structural survey to be carried out. That was done to obviously come up with the solution that we came up with in the end, which is the secondary frame that was added to enable the PCM to be installed. So they did provide us with some information, but at the same time, we have to think about the specifics of our building and also whether or not the structure, because Hasim in his presentation mentioned issues like structural limitations and things like that. So those are the sort of considerations that we have to put in to make sure that the load of the PCM this roof structure can accommodate the extra load of the PCM that we added. Sorry, the second part of your question was?
Well, more sorry, obviously.
The spacing.
The amount of allowing the airflow. So you've got them so close together.
That's right, yeah.
The airflow doesn't get on the round one. Also, just on the, not just the aesthetic of one being
That's
one,
right.
isn't there a more...
I accept that to be an issue. I don't think we received any guidance on that. But I agree with you 100% that now there are a number of issues there. Because the heat exchange between the room and the PCM is by convection, right? It's convective heat transfer. Therefore, some sort of air movement and some sort of thermal interaction between the room and the PCM is essential. The good thing is, based on thermal buoyancy, obviously the heat in the room will naturally migrate to the top. So that is not a significant problem because the location of the PCM is where naturally the room temperature will be highest. So that did not appear to be a major concern, unless of course you have little insulation on the roof, in which case some of the heat will be conducted outside the space. In terms of the number, we received some guidance as to how many, what amount of heat PCM will each PCM tube will absorb. So basically, I think Kasim did some initial load analysis for the heating load and the cooling load of the space, and then we selected the number of the PCM based on the cooling load of the space, effectively, because the guidance that they provided is basically I can't remember the exact figure. Can you remember
per tube, or
how much?
I think
how
you
much
said
heat?
12 tubes per meter squared. I think it was 2.2.
Yeah, right. I think they gave some guidance per meter squared, and as well the amount of heat that every single PCM tube will absorb. So basically, based on our worst case cooling load analysis, the PCM was sized. So the number of the PCM was sized. But I think there are some potential for configuration improvement. I think in cases where you want to really improve the heat transfer between the PCM surface and the surrounding. Number one, I can see that we have a very smooth surface, which of course, therefore the convective heat transfer coefficient will be very small, will be very slow, small. And therefore, so there are some configuration improvement that can be made, and maybe some surface roughness improvement as well, just to enhance the heat transfer between the PCM and the room. But in terms of temperature stratification, I think the location of the PCM basically solves it, because you have the natural temperature stratification near the roof surface. The color as well that you highlight, I think certainly something that worth thinking about in terms of the absorptivity and reflectivity of the surface, because the the heat absorption itself is not by radiation, but the heat contribution to the space is by radiation. So perhaps the reflectivity of the surface could be the most important element rather than absorptivity. Because the heat absorption, the heat transfer is by convection between. Did I manage to?
Yeah.
Okay. But what's your view though on the color? Do you have any?
I just think not that kind of off words, but
Aesthetically,
Okay.
in terms of on retrofits, 'cause I work in retrofits, we tend to find it's more the aesthetic takes the lead in retrofits. That the building services are always not always an afterthought, but you always up against the architect. And in general, in roof spaces, people love to spray the black. So that colour would be quite difficult to. But I can't see why that would be any issue. If not just necessarily not spraying them, obviously, but getting them in different colours. And they seem like a good idea, especially I think in conjunction with other systems. I think they'd probably working in conjunction with ventilation systems could be a really, really useful technology.
Thank you. I think I agree with you. The other follow-up I can have on that is that, well, even if you have maybe not very nice color, maybe the design of your ceiling, suspended ceiling structure, then may actually solve that problem. To a certain extent. Yeah. 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 Exactly. I think so. Absolutely. Thank you. Thank you for that.
Thank you very much for the presentation. That was quite interesting. I've got two questions. First of all, I'd like to know if you have done any economic performance of the project, like how much you have invested and how much investment can be returned and in how long, because some of the buildings might be demolished. And then how long does it take for the investment to be returned? And my second question is about one of the pictures for the rooftop PV panels on Richard Crossman building. I don't know, but I think the optimum tilt angle for the PV panels might be the latitude of the place, but they were really horizontal. I don't know if you have done this one. If it has been done for summer or winter, or what is the optimum tilt angle in this picture? Thank you.
Thank you, Safide. I think in terms of the first question, we did, as part of the project, did a comprehensive whole life cost analysis of each of the technologies. Unfortunately, we haven't presented any of it today, but we do have the life cycle analysis, life cycle cost analysis, and life cycle environmental analysis.
Because I think that's still going on right now. Okay. To have it fully analysed and completed, as in pre-retrofit and post-retrofit, to have a fully analysed set of results, they're being done at the end of the project, which is hopefully in the next month we'll have the full set of results for everything. So instead of having just say the economic analysis beforehand, but while we have the results, actual measurements after as well, we can base the analysis on that. So we have the comparisons probably available in the next month. So we'll have the full set available in the next month, hopefully.
So we did do some life cycle analysis at the beginning, life cycle cost analysis at the beginning of the project during the selection process, because that's one of the indicators of that we use to select some of the technologies for a particular project. So there was some initial cost analysis. What Kasim is referring to is that at the end of the project, this is where the results have been collected of all the monitoring and the energy consumption. So we are now doing a cost analysis based on real results, and that is what is not yet completed. And then you asked about the tilt, right, of the solar. This particular installation was commissioned to a company outside Coventry University as part of the package of the installation. So the design and installation was carried out by an external company on behalf of Coventry University. The angle, the optimum angle, obviously will be specific to the building as well. You need to take into consideration the constraints of the building and the surrounding as well. So I imagine we haven't ourselves reviewed the design, but I imagine that the design that we did is about appropriate for that particular building. We need to maybe look at it again in detail. Do you have anything to add?
I think they did a shading analysis.
They did a shading analysis, yes. They did a shading analysis. So basically, they come up with that orientation and angle based on their shading analysis as well. Because we have surrounding buildings, the tall council building and other buildings, the habitations around the building, which all can provide some sort of shading to that, to Richard Crossman building, or to the roof of the Richard Crossman building. It would have been interesting if we had visited the roof, because you could see it maybe in more context when you see the potential impact of the taller buildings around the Richard Crossman building. In particular, the tall council building, which is not very close, but could have significant impact. So they did some shading analysis. If you could actually model this, maybe this is something that we could do in Coventry to model the buildings within IES, and we could see the impact in different times, during different times in winter and in summer. Now, in the end, you have to optimize your design for the best period of energy generation, which is for the summer period, effectively. And during the summer, the sun is directly overhead. So even the low angle of the solar PV, would be effective, especially given the trajectory of the sun from the morning to the evening. So the lower angles may actually work better in energy generation during the summer, maybe not as much effective during the winter. So it's not straightforward, I think, to answer your question. It's not straightforward. Perhaps this is something we could internally within the university have a look at.
Thank you.
Or you want to add anything? What do you think, Sapida, though? What do you think of the solar angle?
No, now taking a look at the picture, I think that if you just wanted to use another solar angle, you could have implant less solar panels. But now you have managed to have more solar panels. I think this is another reason. You just maybe come up with the idea of having more panels. Because now the roof is covered. But if you wanted to use another angle, maybe the panels overshadow each other as well. Not even the buildings.
That's what
the
it is.
panels overshadow each other as well. So now the panels don't shadow.
I think now that you said that, actually, something popped in my mind in that, and that's a really, really good point. The design of the solar panels was for 75 kilowatt system. But because of the part of the roof of the Richard Crossman cannot accommodate the weight of the panels. So they have to be, I think in the end we installed about 50 mil, I don't know, 56 kilowatt, I think, in the end. Yeah, initially the project wanted to have 75 kilowatt system, but because of some part of the roof cannot accommodate, when they did structural survey, cannot accommodate the number of PVs that was planned for that space. So basically they have to distribute it to the rest of the roof space. And I suspect that maybe that could have influenced the design, because the project, in that particular case, we did not do the design or installation of the PV system. Yeah. So I suspect that may have influenced their decision to go lower. But because of the sun in the summer is directly overhead as well, may have been a factor in that it will significantly influence the performance even if you go for lower angle.
Okay, thank you for the presentation. I have a simple question based on the presentation and then discussions which are going on. I tend to have a feeling that each building will present a different challenge and a different opportunity to retrofit. If that is the case, then what is the lesson that we can learn from this project? I'm coming from the point of view that my country, for example, has an annual average temperature of 30 degrees. What can I learn from this process?
Anybody want to jump in?
We have a replicability study that we took part. So in our project we looked at 3 different climatic conditions. As we mentioned, we looked at a very hot climate, we looked at a very cold climate, and we looked at a climate in between. So we basically selected our technologies based on what the climatic conditions are. That's one of the aspects we took on board. At the end, during the end of the project as well, once we had all this data started coming in as well, we did a replicability study. So we did a study on, say, if we wanted to, say, replicate this type of retrofit in other Nordic countries, or this type of retrofit in other Southern Europe countries. We have this information available, and this information was fairly, fairly good when it came to results. So during this replicability study, we were able to show that the replication of these retrofits was done at a very good standard. So we can take this to different countries and see that it works efficiently. So in that sense, we have proven that in the project potentially. So you can have a look at that and see if that will be suitable for your country in that sense.
I think that's a very important point. I think one of the main output of this project is to demonstrate replicability of the technologies, not only in the specific building, but in the surrounding district, and also nationally, and also in other countries. And you're right to point out, your question is really very pertinent to the issue that we have at the moment globally, because we have to learn from everything that we are doing and to see the context in which all this learning can be beneficial. It's all relating to the impact of a particular project. We can't spend, this project cost about 30 million euros, in everything that we've done, funded by the European Union, and it's only right that the project made significant lasting impact. Not only, the investment was not only made so that we can improve the performance of 5 buildings, the improvement was there to actually replicate some of these results so that other countries can benefit. But going back to the nitty-gritty of the specific context of each individual building, I think that was the kind of core of your question. We had to, that's why we had to do the initial diagnosis, basically building diagnosis. What are the challenges within that particular building? What are the thermal comfort or indoor environmental quality challenges within the building? What are the problems that the occupants of the building are facing? We also have the energy consumption data, right? Historical data about the performance of the building. And those are the yardsticks that we use to kind of determine, well, what are the areas of opportunities and what are the areas of improvement. Monica also presented the user satisfaction questionnaire and the stakeholder engagement that we did. Those are all kind of used as a platform for saying, okay, there is an area of potential improvement here. As I mentioned with the PCM, right? We had to, initially engage the occupants, the people who use that space, and some of their feedback is, this room is, the temperature gets really cold or it gets very hot, and that is the basis upon which we identify the potential opportunity. And I will advise that if you are considering improving any building, you have to do those initial diagnoses first. And as part of that diagnosis, the users of the facility and all the stakeholders that are involved either in the use or the management of the facility should be engaged appropriately. I'm not saying that what we did is perfect, no. I think we are always self-critical that maybe there are a certain level of engagement that we should have done at the beginning to understand the challenges that from the estate personnel point of view to the user's point of view, and make a much more informed decision. It's always, hindsight is always 20/20, as I say. We could have, but we hope that this project has shed the light on the importance of engaging the users and in applying robust diagnosis of the building to be able to identify what those potential opportunities or threats are and how you can solve them. It's so I wouldn't answer your question directly, but I think I would just answer it in that way and say these are the sort of things that needs to be done for those potential opportunities to be identified.
Yeah, Chris Idden from SE Controls. I'm just wondering, this project's coming to an end now. Is there any plans to continue with your post-occupancy evaluation of these products and the efficacy of these products, particularly with the PCM you were talking about, perhaps introducing ventilation and seeing if there's any improvement? What are your future plans?
Absolutely, we do. We are actually thinking of some PhD-based research, which is one way of us getting some free bodies to do to help us do some of the research. And also, Monica may want to say something. We are also putting forward a proposal to kind of look at some of those challenges that the barriers specifically for this sort of technology. What are the barriers for implementation? And if successful, I think the idea is to try to develop solutions, because you have various technologies. Even in this RESSEEPE project, we've identified some of the limitations, some of the barriers for installation and so on, and lack of skills. What we want to do, in the new proposal, if successful, is to kind of understand the barriers better and to develop some solutions. But Monica, you want to add something?
Yeah, as Abdullahi was pointing out, in this new proposal, because as you said, this project is coming to an end, and we need to think how to move forward. So from the different barriers and challenges that we identified in the project, we are trying to put up a proposal to analyze those things so we can continue in the future. And some of those challenges that we identified were, apart from the market barriers of how these technologies can get to the end user, to the contractors, also some barriers in terms of performance gap as well. And also we wanted, because we think that the user behavior is very important and the thermal comfort of the people, we wanted in this proposal to be user-centered, so focused on the end user, and not only analyze the thermal comfort, but also the health and well-being of the occupants of the buildings. So we are trying to tackle those issues in this new proposal.
Thank you, Monica. Yes, that's yeah. So basically, I think, to be honest, we, looking back, I think sometimes when we go to events, we tend to go on our way back or coming back, we tend to say, why can't we talk more positively about these things? And unfortunately, that's, I think academics, sadly, we focus on what didn't work well, right? And how we can make it better. And sometimes we lose sight of a lot of the benefits and a lot of the good things that we've identified. So yeah, I mean, with every project, we tend to always kind of see where are the limitations, where are the, what haven't we done well, how can we do it better, and how can we continue this work that we're doing. And I think there is a lot, we've just, from our point of view, I think we've opened a lot of windows rather than closing a lot of windows. That's how we see it. And as I said, we're identifying PhD students. In fact, we have some of our students who are now doing internship on the project, so anything we can do to continue to improve is definitely what we are trying to do at the moment, and it's top of our minds, basically. There are a lot of good things coming out, but we think that there are a lot of things that we could have done better, and there are a lot of things that we don't have the right answers, and we feel that there is a pathway to getting those right answers. And we plan to continue digging until we get those answers. And anybody in the room wants to do research with us, get in touch. Okay, yeah. We want to engage with industry to continue to disseminate. Some of the results are not yet, at the level where we feel confident to talk about them, outwardly. But at the end, all of the results of the project will be articulated and will be disseminated. And we will continue to do these dissemination activities. If there are any events that you feel will benefit from some of the results of this project, let us know. If there are any areas where you feel there are opportunities to work together to take things forward, we are open to your ideas as well.
Can I just ask a question, Mark? During the time when you were doing the surveys and getting feedback from the stakeholders, were they done on a regular basis, and were the same people involved in giving the feedback?
Regarding the staff in the offices, yes, because they are the same. Well, I think they haven't changed, but it's the same staff. Regarding the architecture studio, some of the students were the same because they were the previous course and also this course, but some of the students were different. But we did the survey to different groups of students.
And the responses were quite consistent, were they, across the different?
Yes, yes. Similar responses.
And what time period? A couple of years or?
Yeah, the first batch of surveys were before we installed the PCM tubes, and then we did again the surveys several months after installing the tubes. Especially because the tubes were installed in last Easter, so we wait until the summer period was finished, and also some of the I think we did them after Christmas. Yeah, so we could analyze the benefit after the summer period and also some of the winter period.
The Richard Crossman have a lot on the roof. In John Lang, we just have the horizontal one, but we only had that as part of what we call a ventilated facade, because we want to have different layers with a ventilation channel in between the PV and the vacuum insulated panel on the wall, horizontal.
Yeah, the disposition of the solar PV panels in John Lang is not the best in terms of performance of the panels, but it's what is called building integrated photovoltaics. So we wanted to integrate the panels in the facade. Obviously, these panels in Richard Crossman, the performance is better, much better.
You talked about that none of the contractors had the experience to install the parts. Let's talk about the ventilated facade, for example. So didn't you have a method statement for installing it and the specifications for it?
Yeah, the technology providers, let me rephrase that. Some of the technology providers provided a method statement for installation. But as you can imagine, if you haven't done something before, even following the method statement becomes a little bit more complicated. Lack of experience always is a hindrance, to effective or the installation process basically takes either longer or there are some issues. Because if I give you an example, Monica showed in her presentation, in the presentation earlier, the vacuum insulated panel. Even though the technology provided a method statement, but still the way the installers kind of treated the very delicate materials suggests that they really didn't understand. Method statement is one thing. Understanding really the impact of your action is another. Because we think that the way they treated, they just throw them however they want, and even though there is clearly instruction not to use nails or anything like that that could break the seal and therefore evacuate the vacuum, they still treated the materials, in not very careful way. So there are, if they are very experienced with managing this sort of installation, they will probably take a little bit more care in dealing with the material. So it's not really the fact that the installation process, as Monica highlighted, are very difficult to do. The fact that they don't understand the type of material, or they've never worked with the type of material before, raises some doubt in their mind, or it makes them kind of treat them like normal, like a brick that they can just throw on the floor and nothing will happen to it. And clearly in the case of the vacuum insulated panel, it had an effect. Because just installing how many number? About 6 or 8, they still damage one. So that's basically 20%. So imagine if they're installing 100, they would have damaged like 20, right? So that's the problem. But for the PCM, they did provide us some potential solutions. But again, you have to think about when you contacted somebody and say, well, we want you to install these tubes, right, these PCM tubes, the first question would be, what are these? What is PCM? Right? So it just sows some doubt in the minds of some potential installers. But in the end, as Monica said, when they realize that this is really straightforward installation, it's just brackets and kind of secondary structure and so on.
PCM is one thing, and the ventilated facade is another thing, in my opinion. But you indicated before that the results you got were much less than expected.
Sorry?
The results you got, the reduction in the values you got, were much less than expected.
For what? For the ventilator facade or for the PCM?
For the whole system. For the reduction in the energy usage, as an example. So, the method of application and installation of the materials could have had a great impact on that.
Yes, you're right. You're right that in the installation process and the quality of installation could have significant impact. And that's why when we talked about the performance gap, even though there are many other reasons for performance gap, the installation, the quality of design and installation could be one. You have issues such as thermal bridging. And if you have a bad design, obviously you can have a lot of thermal bridges, which could be significant component of your heat losses, which in a lot of cases are not accounted for.
I think, can I add one quick thing about the vacuum insulated panels is when they were installing it at the John Lamb building, that was more like a lesson learned sort of thing. When they did install it at the John Lamb building, they found that there was a bit of damage to the panels. The vacuum was lost. But they did a very similar installation in Skellefteå with an improved method statement after the John Lang installation. The one in Skellefteå had no problems whatsoever, no damage at all. So it's like it's one of these ongoing processes where it's a lessons learned sort of thing.
I think in order to see the results, you need a full electron. It's not a point talking about the windows without changing the walls. It's not about putting a new ventilation system if you don't have good windows, and so on. So, it's a whole package.
Yeah, I will agree, because if part of your fabric is weak, Obviously, heat will always find the area of the weakest path, you know, to leave the building. So I totally understand, I appreciate that. In the John Lang building, what we did was to try to apply to a localized area, and we can test specific area. What we are trying to test, for example, in those areas is heat flux. And it doesn't matter whether we do it for the whole room or just for one section. We can test, we can have a heat flux sensor to test the heat flux, and we know the delta T between inside and outside, and we can determine what the U value of that particular material is. But I agree with you, if you're retrofitting the whole building, there is absolutely no point to have these single glazed metal frame buildings while you're having heavily insulated walls. There will be significant, you know, thermal breach, so that will not be the best approach to use. I have to reiterate that the John Lang building was only used as a living lab. It was an experimental building where we just test different materials. It's not supposed to anyway provide significant improvement to the performance of the building. As such, we are trying to test individual material, but we want to test it on buildings rather than just in the lab. We have environmental chamber that we could have done it in, but it's better to test it on the building itself. But your point is taken, you're absolutely right. It's better to moderately kind of improve the building all around than to heavily insulate parts of the building and parts are very poorly insulated. Again, please, if there are any experiences in the floor, we will welcome your input. And I'm sure we have a lot of students who will benefit as well from your experiences. So if there are any comments, please. In the absence of any questions or comments, I would like to thank all of you for making the time to come here today, for your very useful questions and comments. And we hope to create further opportunities to have similar sort of events because we have a lot of results that we would like to make public. So I'm sure we will create similar opportunities in the future to do this. And Lionel, you want to add something?
On behalf of SIBSI, I'd like to thank you for attending as well. Those of you who are SIBSI members, thank you again for continually supporting. Those who aren't SIBSI members, you're more than welcome to speak to myself about becoming a member if you're interested. It's a very developing, dynamic community, and we're looking to try and engage as many young engineers, not just within building services, but within engineering as a whole, to try and get involved in what we do. The environment and the conditions that we have within the world as well needs to be dealt with, and I think building the building stock around the world is one of the areas where we can make a very major impact. So if you are interested in getting involved in SIBSI, please can have a talk afterwards. Thank you very much.
Thank you. Thank you.